Hello, everybody. We're here for the Research Showcase, September 2016. And today we have two guests. First, I'm Abby Ribstra. I'm the lead design researcher here at the Foundation on the research team. And so today our speakers are Besnik Fetahu, who's going to speak about finding news citations on Wikipedia. And then Amy Zhang will be speaking about designing and building online discussion systems. So at the Research Showcase, each presenter will have 25 minutes, and then we'll have about 5 minutes for conversation. There's the IRC channel that you can ask questions through, the Wikimedia-research channel. And Aaron Halfacre will be there making sure we ask questions to the presenters and hear their responses. So with that, Besnik, it's all yours.
Thank you, Abby.
Does anybody have any other questions before we begin? I know that Amy had some questions that she related to me over email.
I'm good. I got the answers earlier. Thanks.
Okay, cool. Sorry to interrupt. Go ahead.
No worries. Okay, cool.
Okay, so I should be sharing the screen, I suppose, now? Okay, so thank you, Abby, for the introduction. So as you said, so the work is about finding news citations for Wikipedia. This work has been done together in collaboration with Katja, Wolfgang, and Avishek here at L3 Research Center in Hannover. And without further ado, I'm just going to jump into the motivation behind this work. So one of the main motivation point was the actual one of the core policies in Wikipedia, that is the verifiability. So what that means is actually that statements which are added in the entity pages or Wikipedia articles should point to an external reference in order to serve as evidence. So basically there are some guidelines on how you can actually cite in Wikipedia itself, and one of them is, for instance, that you should cite third-party sources which come from reliable and authoritative sources, for example, like news, and in order to have also this objective point of view with respect to some added statements. The other motivation is that actually, if you see in Wikipedia, many citations are actually outdated or point to dead URLs. Apart from that, there is statements which have citation needed markers, and this is usually the case for long tail entities. However, this can be also for newly added entities. And yeah, since we can imagine that Wikipedia is constantly evolving, therefore in this case you would a preferable system would be something that actually manages this in an automated manner, so that you can enrich by means of finding citations or actually just providing suggestions to the Wikipedia editors to provide actual citations to the statements. For this kind of problem, we propose the following approach. So as input, we have the Wikipedia entities, and we kind of decompose the entities into the kind of more atomic parts like sections, the anchors which are within the section text, and then we have the categories and so on. So for example, here we have Barack Obama. We know that Obama is a type politician. We can get this through any knowledge base or through the categories in Wikipedia. And then what we do is we decompose it further into the statements. So here, the first step that we need to do in order to find actual news is to make sure that a statement actually requires a news citation. So what we do is statement categorization. Here there are several categories that a statement can have, let's say, based on the citation type. For example, it might be a web, a book, or journal, or other reports. Let's take as an example that Obama, for example, was elected to the Illinois Senate in 2007 or something, and this requires a news citation. So now in the second step, what we need to do is find actually this news article which serves as evidence for this statement. And you can imagine you might have a real-world news index, and from that kind of you can use the statement as a query and find out the actual citation. However, as we will see later on, this is not actually a standard retrieval task, and it's much more complicated, and you need to follow quite some guidelines which are actually stated clearly in the Wikipedia policies. So let's begin with the first task. So the statement categorization. Let's take again Barack Obama. Here we have 3 sections. One is, let's say we have the 2008 presidential campaign, then we have legislative career, and a section about early life and career. As you can see from here, in the first section, in the presidential campaign, these statements are very news-like. So there's these events which have very broad and high coverage in news media, and you would expect a citation to be found there. However, if you have, for example, the legislative career, you have laws that are being proposed, laws that are actually passed, and so on. So for these kind of types of information, you might find it also in news, but a more preferable source would be a report which is coming from some governmental body. So in this case, you would actually want to find the, let's say, the more suitable citation type or citation source. And as I said, we focus in news in our case because news is the second most cited source in Wikipedia. And apart from that, it has quite some nice features, like it's ideally it goes through an editorial board, so information that is kind of reported in news, it's accurate and in many cases also true. So we focus on news, and in order to do that, so we pose this problem as a classification problem. So we have a statement and we want to classify it into one of the citation categories. So you have web, news, book, and so on. And for that, what we do is we analyze 2 types of feature. One goes at the language level. So we analyze the statements and their corresponding language. So what are some attributes that we might find in news? And we further analyze the structure of the Wikipedia entities. And in more detail, for example, language features are like quotation marks. So this is a high indicator of paraphrasing, and you see this a lot in news articles where somebody actually quotes a third person, and this as well is also seen in Wikipedia. And another thing is temporal proximity. So for example, here you have two cases. One is the first statement is about Barack Obama, and the second one is about Leibniz. So you can see that in the first statement you have a temporal expression or a time point which refers to 2003, which if you compare to the current time, it's not very far off. However, if you see the second example, that dates back to the 17th century, so it's very unlikely that such a statement dating back to the 17th century will actually point to a news article. And another feature which goes into this group of language features is the discourse. So we perform a discourse analysis on the statements, and what we expect and what we see also in news is that news have this temporal discourse. So you report about events, sequences of events in a temporal manner. So you have this temporal discourse, and we expect this to be found also in the news statements and not in the other, for example, in books and so on. So this is the first group. Now consider you have, let's say, several statements, and we focus on this one. And here the other type of features that we consider for this the statement categorization goes into more the structure of the entity. We know that certain sections and certain entity types are, let's say, are more likely to be found in news. For example, here that, as I said, the presidential campaign section will be very likely to have news citations. And if we combine this, let's say we sort of measure the likelihood that, given that this entity is of type person or politician, and I'm analyzing a section about presidential campaign, how likely it is that I can have here a news statement. Similarly, we can further analyze the statement itself. So in the statement we have this anchor text which points to other entities, and what we do there is basically we know that we are analyzing Barack Obama, which is a person or a politician, and we see like what is the likelihood that as a politician it co-occurs, let's say, with an organization or something similar in a news context. So we simply measure here the likelihood and then combine all these features into a supervised model and try to predict accurately the news category. As I said, the classifier is a multi-class classifier, but the features are sort of optimized for news citation. So once we determine that a statement is a news statement, basically it belongs to the news category, then we proceed further into the actual challenging task of finding the citation. So in the citation discovery step, so again, we have now a statement which is categorized as a news statement. And what we need to do is we need to find in our big news index the appropriate news articles. Let's say we do a query and manually find out that actually, as many of the Wikipedia editors probably do it, we find out that these two news articles are the most appropriate ones for this particular statement. And actually, these are already in Wikipedia itself. So what we see here and what is also represented in the guidelines of the citation policies is that there is a definition of what makes a good citation. So first of all, the statement itself from the Wikipedia entity should be entailed in the news article. So we need some form of entailment or similarity between the statement and the news article. The second point is that the statement should be central in the news article. That is, for example, here you have an article talking about the launch of the presidential campaign by Obama. However, you might have a similar article which reports about all campaigners. So you might have a summary of all these persons participating in this election, and therefore you would prefer the one which is, let's say, more focused towards the specific entity or person. So this means that the statement should be central in the news article itself. And the third attributes which defines a good citation in our case is, and in Wikipedia itself, is that the cited news article should be from an authoritative source. So if you have, let's say, BBC or CNN reporting a news article, you would prefer it over, let's say, a local newspaper. So these are some of the features which make a good citation, and we build upon these to actually to extract actual feature for our problem. So the discovery process goes in these main steps. So now you have a statement, and from this statement you need to construct a query. Since not all terms are equally important, you would want to actually retrieve from a news collection index the most important news articles that match the most important terms. And from that, we made quite some extensive analysis, and we found out that actually if you go further than the top 100 news articles retrieved by this constructed query, for which we use related work as shown in the slide, you do not gain much in the coverage, meaning that if you retrieve top 1000, you won't be finding any relevant news articles at all. So we found the best threshold to be at top 100. And then after that, you compute these features which make a good citation between the statement and these top 100 news articles. And in the end, you simply classify these pairs of the statement and the news articles as either being a good citation or not, or simply like, is it appropriate citation for the statement? And so in more details, so what are the features? So the first attributes that we were looking was entailment. So we do this in this manner. So we first have a news article candidate, which we retrieve from our index. We chunk it into sentences, and then we simply compute the similarity or the entailment between the statement and the individual sentences. For that, we rely on Jacquard similarity, phrase overlap, proper noun phrase overlap, since these are kind of indicators of named entities. And then since this kind of, let's say, if you compare Jacquard, it's kind of a bag of words similarity. For that reason, we rely on more sophisticated similarity measures like tree kernels. So in this case here, you would actually consider this in semantics and the syntax of the sentence. So actually, the structure would be similar, and also the semantics of the sentence between the statement and the sentence in news article would be the same. And furthermore, we compute language models over the news article candidates and see like how likely it is that we can generate such a statement from this model. And as you can imagine, since news articles have different number of sentences, we normalize this across per article by taking the average across these features and minimum and weighted average and so on. And the second attribute which we were focusing on was that actually if we have high entailment, this should be also that the sentence with which we have entailment, it should be central to the news article. In order to do that, what we do is the following. So we decompose again the news articles as a set of sentences, and then simply compute the pair by similarity between each sentence. And if the similarity is above some threshold, then we construct an edge. What this gives us a graph over these sentences, and then you simply can run like a page rank like algorithm and find out the most important sentence. So this is some work which has been proposed in 2004. You can see the reference in the slide. And then basically we have again the entailment features between our statement and the most central sentence in the news article. The second kind of centrality feature that we consider here is some work which we proposed last year. Since we are dealing here about a specific entity, necessarily the entity should be a salient or central concept in this news article. So the news article should be about this entity. So we cannot really like propose a news article which doesn't have to do anything or the entity is not salient in that news article. So the entity should be salient, and this kind of like further emphasizes the centrality attribute for the citation. And the last feature that we consider here is the authority of these news articles. So basically from the news domains from where they come from. So here you have two types of entities. One is an athlete and the other a politician. So here, if you have a news story about, let's say, Stephen Curry, you might prefer actually that this news article should come from more specialized sports news domain like ESPN, Sky Sports, and so on. And the other case for Obama, for example, you would prefer BBC, CNN, and so on, because these are more specialized in politics and so on. So these have higher authority for certain entity types. So we further kind of decompose these news domains into these entity types and prefer, we simply compute, let's say, what is the authority of, let's say, ESPN in the different entity types, and in this way we can establish this news domain authority. So once we have computed all these three different attributes in forms of features, we feed them into a classifier and then train a binary classifier in order to say like what is a good citation and what is not. So let's see what is our setup here for the experiments. So for the first task in the statement categorization, we extracted roughly 6.9 million Wikipedia statements, and these point to 8.8 million citations. So these are citations from all sorts of types. And these are coming from mainly 1.6 million entities and roughly 670,000 sections. And as you can see here in the plot, web and news are the two most popular citation types in Wikipedia. Whereas for the second task, we have for the citation discovery, so we extracted roughly 1.88 million news articles that were cited from Wikipedia news statements. And here we had to kind of, in order to have a realistic evaluation experimental setup, we had to limit it between the ranges of 2013 and 15. So the news articles should have been, let's say, posted or published at 2013 between these two dates, because our real world news index, which is GDELT, an index of over all English news media across the world, was within this range. And for that, we had roughly 20 million news articles, and we kind of merged these two news collections together and as you can see, this presents a really realistic setup with 20 million news articles which were not actually coming from the Wikipedia itself. So finding the already cited news articles from Wikipedia is quite a challenging task. What we realized is that before we actually started training our models is that for the statement categorization, the ground truth is quite mixed up. So for that, so here in the bottom of the slide, you can see one random example which I took. This is about a person in UK, and it has a statement which points to a citation in BBC. It's obviously a news article. However, in the actual citation type, you see web. So this is clearly kind of a mismatch of the citation type. And what we propose here are two simple heuristics. One is we simply do majority voting, where we count how many times this news domain actually appears in one of the citation types, and we pick the one which has the majority, and the rest we kind of move to that majority type. And the other heuristic which we propose and use to clean up this ground truth is that in case we find kind of as a subdirectory in the URL news, then we would mark it as a citation type of news. And in the table here, you can see in the left hand side of the slide the changes from one citation type to another. So the most of the changes are between web and news. So for example, from web to news, we move around 1 million citations, and from news to web, roughly 400,000. So by simply applying these rules, we kind of clean up a bit the ground truth. However, there are still noisy data in the ground truth which need more sophisticated approaches to clean up actually the ground truth. And for the citation discovery, what we, from this 1.8 million news article, we realized that 19% actually point to dead links or to moved content. And after crawling these web pages, we see that 7% are actually shorter than 200 characters. And in manual inspection, we realize that these are actually pointing to the main page of the respective news domains. And in some cases, they are really basically containing almost nothing. So we discard also these news articles which are less than 200 characters. And so now the task is, obviously the first task is to categorize the statements, and the second task, we have to find these actual citations, news citations. So for the... Yes?
You have 5 minutes, I just wanted to let you know. Sorry to interrupt.
Thank you. Okay, so for the first step, so the evaluation is the following. So here, one obvious fact is that you cannot really mix different entity types because they have completely different structure. Like you cannot mix a location with a person, since the language features and all the entity structure features are completely different. So we train classifier which follow this type hierarchy, which we extract from Yago. So we start with very generic types and then move to more finer grained. And as you can see here in the table, for location, we perform really poorly. Some reasons for that are that locations do not have that many new citations at all. And for the other case, for person, we perform reasonably well with almost 70% accuracy. However, if you go to more finer grained types, the performance starts improving. So, one conclusion that we see from here is that for some types, you actually should not try to do automated approaches because they do not perform well. And for some, you can actually categorize with reasonably good accuracy the categorization task. And in the second evaluation, here it's a bit more complicated. So we actually use some baseline just to show like the difficulty of this task. And the baseline is the following. So we take the top one document news article that we retrieve from our news collection, and another baseline which we propose, which is simple model trained on the rank of the document and the retrieval score that we get. And in the first evaluation, basically where we are evaluating our approach, is we try to find the actual news citation that is already in Wikipedia. As you can, if you remember, you had 27,000 news articles in a news collection of 20 million. So it's quite a challenging task. And another thing which we realize is that many news articles can be duplicates. So what we do here is we, the false positives by our models, we measure their similarity to the ground truth news articles. And if it's above a threshold of 0.8, then we consider them as relevant as well. And for the remaining false positives, we simply ask the crowd and show them in pairs of ground truth news articles together with our suggested news articles, which are false positive because they do not exist in the ground truth, and ask them to evaluate based on the statement which one would they prefer. It's either one of them or both or none of them. The result for this evaluation are the following. So as I said, the baseline is not really suited for this task because it's much more complex and simply retrieval, and it performs as expected quite bad. And for the first evaluation, where we try to find the actual citation in Wikipedia, then we perform reasonably well with almost like 70% accuracy based on micro average across all types that we compute this process. And once we add also the false positives, which are very similar to the ground truth, this further improves by 5%. And then when we ask the crowd for the false positive to assess, we get an improvement of over 22%. So what we can see here is that actually the citation discovery can be done with high accuracy, for some types even with 90% accuracy. And as you can imagine, this task is very difficult because we have to find the correct citation between a list of 100 news articles candidates. And what we further can do through automated approaches, we can actually suggest better citations. So here in this small table, you can see that in almost 20% of the cases, we were able to suggest better news citation than the existing one in ground truth, while in 38% of the cases, both the ground truth and our suggestions were equally good. And to make it shorter, since I don't have time, the conclusions from this experiments and these proposed approaches that you can actually maintain one of the core principles of Wikipedia, namely verifiability, by doing an automated approach which first categorizes statements into news statements and then try to discover news articles which serve as evidence for these statements. Important aspects to consider here is that how you construct queries from statements, and there needs further work to be done on actually cleaning up the noise from the how these citations are categorized by the Wikipedia editors in order to have, let's say, more accurate and reliable models. And with that, I would like to thank you and open for any questions that are available there.
Thank you, Besnik.
Thank you.
Aaron has some questions on IRC.
And fun story, these are all for me because I didn't get any posts through IRC. By the way, if you are on IRC and you're hearing this, ping me. I'm Helfak. I'm basically the only person that's talking in the chat.
Okay, I haven't, because I had both screens kind of blocked, so I didn't see anything.
Oh no, that's just fine.
So I'm just timing it for 5 minutes so we make sure Amy has enough time.
So the first question that I had was, why detect news statements first? Why not just look for relevant news citations for all assertions in Wikipedia?
Yeah, so we had, initially we were thinking in that way. However, you might end up, so you might have, let's say, a collection of, let's say, books, news, or reports, which is your target to find citations from for the statements. So in this way, what you can do is actually suggest a new citation only when it is necessary for a statement. So as I mentioned in one of the slides, you might be able to find news citations for statements which actually require a report from a governmental body, but however, this is not really the most appropriate citation for that statement. So it is better to first make sure that this statement actually requires a new statement, new citation, and only then actually find these news articles. You can do it in both ways, but I think in that way, if you do not do first the categorization, then you might be introducing some noise into these or not really appropriate citations. So that was one of the main reasons for that.
Okay, I have more questions, but we should probably let people in the room ask some too. Thank you.
There's no one in the room but me, and I'm sorry I don't have a question right now.
No problem.
So, Aaron, if there's another one you'd like to ask, you can do that, or we can move to Amy.
Okay, so this one's a little bit more technical. So when you were going over your entailment measures, one of them was a tree kernel, and I was wondering if that's like a probabilistic context-free grammar.
So what we do there is actually we compute the dependency parse trees of the sentences and the statements, and then simply it's the maximal subtree match. So you try to find the from the statement the maximum subtrees that match this statement. And in this tree, so since it's a dependency parse tree, you let's say the part of speech tags match in both cases, and furthermore they should match, and furthermore they should be also have the same content. So in each of these nodes in the tree, they should have the same words. So in that way, you have the semantics and the syntax of the sentences. There's a paper which actually proposed this. I didn't put it in the slide, but it's in the paper, the reference, which points to this tree kernel.
Gotcha. So that sounds exactly like a probabilistic context-free grammar scoring system. Are you familiar with these? Do you know what the difference is between the two?
I might not really. I wouldn't be able to explain it exactly. But
okay, well maybe we can chat later. Thank you so much.
Yes, no problem.
Thanks, guys. All right, so now Amy, I'm gonna. Are you ready to? Amy will.
Yeah. So I just need to share my screen.
Yeah, just there's a green box with an arrow over on the left. And then I'm just going to push the timer for 25, and I'll, and maybe if you could push presentation. There you go. Perfect. Looks great.
There? Okay, you got that? Okay.
I'll just break in just quickly at when you have 5 minutes left.
Okay, thanks so much. Okay, so I'm going to be talking about designing and building online discussion systems. And this is a project that I'm working on with my advisor, David Carker. And we are both in the Haystack group at MIT CSAIL. So basically what I'm going to talk about is first go into some of the problems with online discussion systems today, and then delve into a particular project that we are doing to work on collaboratively summarizing discussion. And I'll talk a bit about the technique that we use to summarize discussion, the tool that we built, and then our evaluation of the tool. Okay, so there's a lot of places for online discussion, but a lot of them also have problems. So right now, with basically any discussion out there, they can only ever grow in size. And as discussions get longer, it becomes impossible for people participating in the discussion to read everything before they add their piece. So this leads to issues like too much content for any one person to be able to sift through. So here's an example of like a CNN article. I just pulled a random one off, and there are 1,000 responses. Nobody can read 1,000 responses, so why do we show users all of it? Another example of just like a forum, and for each of these threads, there's over 100 pages and several thousand replies. An additional issue that is exacerbated by volume, but is an issue of its own, is that a lot of these conversations can be really deeply threaded or have a lot of replies sort of replying to each other. And oftentimes you really need to, you can't read these out of context. You need to read them in full to understand what was discussed. But this leads to issues when you have deep threading where you can't follow, or it's difficult to follow the thread of conversation. So here's an example from Reddit. I also pulled an example from the Wikipedia talk pages. And this happens in a lot of places where there's a lot of discussion. So here's Twitter. And an issue that sort of exacerbates these issues and is exacerbated by these issues is that there's a lot of redundant conversation and redundant comments as well. Since there's already too much to read, so users don't bother checking to see if someone else has already said the thing that they were going to say or asked the question that they were going to ask. So then they ask it anyway, and then you have this redundancy. So now I'm going to talk about this tool we built called Wikim, bridging discussion forums and wikis using recursive summarization. And this is going to be presented at CSCW next year. So what we tried to do here with Wikim was to address these kinds of discussions that they're too large to read, they're too deep, they have a lot of redundant conversation, or they have these kinds of conversations where you have a back and forth and there's some sort of consensus or conclusion or sort of like a summary of the discussion where anybody who is going to go through and read it later, they only really need to read that as opposed to going back and forth. So one way you can do this is with textual summaries, but this can be really hard for a single person to create. So if you have a really long discussion, you can't really keep all that in your head when writing a textual summary. So one thing you could do is have a collaborative summary. And there are some applications out there that have tried to do something like this, mainly in a wiki-like format. So one example is Quora, where they've had added in some of their pages answer wikis at the top of the page, where anybody can participate. It's just a text box, and you are attempting to summarize the answers that happen below. But there's a lot of problems with this type of wiki, which is that the wiki itself is completely not connected to the discussion that's happening below. So if you read one portion of the wiki that's talking about a particular answer, you won't be able to know until you go through and read the answers and find that out yourself. Another issue is that you actually don't know how much has been summarized versus not. So maybe somebody started writing an answer summary and only got to like the first answer and then didn't bother continuing. So when you read that summary, you're not really sure if you're actually getting a summary of the whole thing or just a small portion. And then finally, there's only one level of detail. So maybe somebody wrote a summary, but it's really, it's like a one sentence, or it's just too short for what you want. So you can only read that, or you can go through and read through the different answers. So instead, we had a different idea with Wikim. So I'll explain sort of how Wikim works first. So say you start off with a long discussion, and then you have a reader who's going through and reading the discussion. And then while they're reading through a short thread or a particular comment, they can, at that point, then summarize it. So not the entire discussion, but a small segment of the discussion. And then the portion that they summarized then gets replaced with their summary in the discussion thread, so that the next person who comes through and reads gets the summary. They read the summary, and then they can decide whether or not they want to open the summary to see the comments that happen within that summary. And then on top of that, then anybody can edit anyone's summary, and then we keep that edit history. So basically the summaries themselves are wikis. And then people can also write summaries that contain other summaries. So if you have somebody who's written a short summary and in a deep discussion thread, and it's been replaced by that summary, then someone else who's coming through and reading at a slightly higher level can write another summary, and that encompasses that summary. And then we call this recursive summarization. So to get a little bit more deeper into the different things you can do in recursive summarization, I have a little diagram here. So on the left, you have a discussion tree. So each one of these nodes is a post, and you have a link from a post to another post if that post is replying to that post. So in this first one, somebody chooses to summarize this small subtree of a parent and two replies with the summary. So then in the next panel, that the dark orange is a summary node, a summary post that's basically injected itself between the comments that it summarized and the parent of those comments. And then we have the light orange symbolizing that those are comments that have already been summarized. So you can group sort of subtrees like this. You can also group different comments at the same level. So below in that second panel, you can see we have 3 replies to a comment above. So you can select comments at the same level and summarize those together as well. Moving to the third panel, you can also move summaries around. So if you were wanting to, for instance, summarize at a higher level, you want to summarize this big chunk of discussion, and you see that somebody's already written a summary that is summarizing a smaller portion of that discussion. And you want to move the entire text of their summary up to where you are and then edit it to incorporate the new comments that are going to be in your summary. Well, you can just move it up, promoting a summary. So then you continue working, and then at the end, you have basically an entire discussion that's been summarized, and you have different summaries at different levels of the discussion. So we call this a summary tree. So it's a summary document that can grow to reveal summaries at deeper levels that cover smaller portions of the discussion. And if you're interested, you can click in all the way to get to original discussion. So compared to a wiki summary, our design of Wikim was so that people could immediately see what was summarized versus not. So you can see that by the delineation of what's a summary and what's an original comment. We also link the summaries to the particular parts of the discussion they summarize. So, if you click on a summary, you'll see exactly what discussion it's summarizing. Also, because of the way that we sort of modularize this, this breaks up the summarization tasks into these smaller, more manageable chunks for people to work on. And then finally, the summary tree that we have in the end is a sort of like a hypertext document that creates summaries at different levels. So here's a screenshot of the tool that we built. This is sort of like an instantiation of our idea. There are different ways that you could create a tool like this. And you can play with it at wikim.ccl.mit.edu. So just to describe some of the things that are in the tool, on the left, there's a directly manipulatable tree visualization where you can select particular comments and it shows them on the right. You can also toggle the different levels, and you can drag to select a certain portion. We also have these editing modals for summarizing individual comments, also known as TLDRs, or you can summarize groups or subtrees of comments. So what you would do is you're reading the discussion. You might select some nodes on the left, or you might just click in onto the comments on the right and say, I want to summarize this. And then this would pop up, and you can write your summary in the text box on the right. Within the editing modal, we have a couple things to help make the task easier. So for instance, we really encourage citation of paragraphs, entire comments, by adding these buttons on the left-hand side where you can cite particular things in your discussion. We also allow quoting, so if you highlight over a particular sentence, there'll be a quote button, and then it'll automatically get added to the summary on the right. We also, so we were interested in some automatic approaches and using automatic summarization techniques to help out the users. Unfortunately, we couldn't really find any that were good enough that they could just be used without the input of the user in terms of extractive summarization techniques, and unfortunately abstractive summarization techniques. So ones that are not just taking sentences from the original document. Most of them require a lot of training data, which doesn't really exist for this task. So we were stuck with extractive techniques. So instead of actually, letting users click a button and an abstractive summary, or sorry, a summary, extractive summary appearing on the right, we have this highlight feature where we're using an algorithm to highlight the top sentences for the users. Okay, so now I'm going to talk a bit about the evaluation of this tool. So we first wanted to evaluate the summarization process. So how easy was it for people to summarize using the Wikim tool? And as our comparison, we used Google Docs with track changes on. This was sort of to mimic what people would use today if they were going to summarize a discussion. Probably something like a wiki editing box or a doc where people can see what other people have edited. And to do the study, we got 20 participants. We divided them into 3 different groups, and each person in the group was summarizing a part of a discussion, and then the next person in the group would build on the work of the previous group. And we counterbalanced the order of Wikim and Google Docs. We also had 3 different types of discussion. So one discussion that was sort of more social. It was the Why Women Can't Have It All Atlantic comment section. Another was a deliberative discussion on a mailing list regarding a political event. And then we also had a discussion from Reddit, from the Explain It Like I'm 5 subreddit. And then, so this is what a starting point in Wikim would look like. So we have just the entire discussion. There are no summaries. And you can see that the discussions that we chose were quite long, like something between 7,000 to 8,000 words, which would be around 30 or 40 minutes reading time for one person. This is how it would look in Google Docs for someone just starting out in Google Docs. So we just pasted the discussion in. We added like IDs in case people wanted to do any citing on their own. We added the like count and also the author. And we added some indentation to indicate the reply structure, but we only had it up to 4 levels and then flattened after that because of space. So this is what a partially completed summarization would look like in Wikim. You can see some of the discussion has been replaced by orange nodes, which are the summaries. And while other portions are still left unsummarized. I didn't mention this, but Wikim also has capabilities for tagging. So you can filter by tag. You can also filter by all sorts of other things. And you can see the citations in the summary. So if you click on any of the citations, it'll jump to the portion in the discussion where that citation points to. Here's an example of, from our evaluation, a partially completed Google Docs summary. As you can see, there are the people, the different people that participated in our study and the edits that they made. So they had started a summary and different people had added to that summary. And then the portions of the original discussion are still there and they are crossed out. So now to our results. Overall, Wikim was faster for summarizing than Google Docs, even with the same groups of people summarizing. So in this graph, we have here group 1, which were the same people, and they worked on summarizing the Atlantic article in Wikim and the Reddit science article in Google Docs. And you can see that for all the groups that are using Wikim, the summary is actually finish. So finish in this sense means that we set it at 250 words, which is about half of a page as sort of the final summary. As all the discussion has been collapsed into 250 words, then we'd say that it's finished. And all 3 groups were able to do that for Wikim, but by the end of our study, none of the Google Docs had finished. And actually, you can kind of see in this graph, some of the discussions actually sort of leveled off. So some other findings, and maybe some ideas for why this happened in Google Docs versus Wikim. So in both conditions, people were really reluctant to edit each other's work. The Wikim condition, this meant that when somebody wrote a summary, not that many people went in and edited their summary after they had written it. In the Google Doc version, This basically meant that most people were writing summary text and appending it to this ever-growing summary at the top of the page, which was just getting longer and longer. So many of the Google Doc pages were like greater than 2 pages long by the time we were done. People were not really condensing any of that down. So as time went on, we saw that stalling because, you know, at some point the summary was basically longer than the amount of discussion, that original discussion that was still there. Also, we saw that users reported spending a lot more time reading in the Google Doc condition as opposed to the Wikim condition because they needed to see what had been done already, see what still needed to be done, sort of get a sense of what was going on in the document. And something else that we found was interesting was that users reported summarizing this content was harder for things that they disagreed with. So we specifically chose some like controversial or subjective discussion topics to see how people would react to summarizing that content. So this suggests that, you know, having training or having some indication of like using neutral point of view would be useful.
Amy, I'm just sorry to interrupt, but people on the YouTube stream are saying they can't see your presentation. Could you unshare and re-share your screen?
Yeah.
I can see you sharing right now. But let's just give it a whirl. Yep.
I'll unshare.
Yeah.
Share again. And now I'm going to press play.
Cool.
We'll see if that works. Let me know if it doesn't. I can also post these slides later. I don't know. Yeah. Okay. So here's a quote from one of the users. This person said, "A lot of times I would look at a comment and all the sub-comments and be like, well, I can't summarize all that. It's really overwhelming. But then I was able to drill down into the sub-comments and get the whole comment subtree and sub-comments into my head at the same time, write a summary, and then go a level up." So this is sort of what we were anticipating with taking care of in Wikim. Okay, and then we also did a second study where we tried to evaluate the created summary artifacts in both Wikim and Google Docs. So we recruited 13 more participants, and each person was given 10 minutes to skim the completed summary in Wikim with the ability to, you know, see all the original comments and lower level summaries. There's also a summary in Google Doc. So this is the complete artifact where there's a summary written, and the original comments are deleted when they were summarized by the participants in the previous study. And we also added an outline, so you can see an outline in Google Doc where people can click to particular parts of the summary to make it easier for them. And then we also had as a control just a completely unsummarized discussion in Google Doc, so the original discussion. So 10 minutes is not enough time to read that entire discussion. Since I said earlier it would take around 30 to 40 minutes, so they really need to sort of skim in that time. And then afterwards, we gave them a survey where they had, there was a list of 12 points that were, 6 of them were in the discussion, 6 of them were not mentioned in the discussion. I was able to get sort of reasonable points raised by looking at portions of the discussion that were not in our study, but were in the original like comment thread that we grabbed it from, since we only took a portion of the comment thread. And these points I came up with before doing either of these studies. And so then we asked people to...
You have about 3 minutes, sorry.
Okay, yeah, great.
Cool.
Yeah, we asked people to select what they remembered. So the results from that, overall users remembered the points more accurately in Wikim versus Google Docs and the Google Docs with summary and Google Docs with no summary. But there was no difference, statistically significant difference between Wikim and the Google Doc summary. There was a significant difference between Wikim and the Google Doc no summary. But you know, with 13 users, that's not too surprising, although we would like to do this with a lot more users. And we found while observing people reading through the different summaries, most people would explore Google Doc linearly, while in Wikim, they could export linearly, but some of them chose not to. So they took like a breadth first approach, or they did depth first, or like some combination of those two. In terms of some other findings, so some users stated that they preferred reading linearly down the page, while other people liked being able to drill in. So thinking about people's preferences for digging into a discussion, being able to see how long a discussion is before they click on it, or the entire size of the discussion. So thinking about the presentation of the summary tree. And then also we found that people would open the summaries in Wikim to read the original content for different reasons. So some of them were like intrigued by the summary and they wanted to read it, so it was like a good summary. But other people thought it, you know, a summary was not good and therefore they should open it. So one quote from a participant: "It felt good on a few comments. It was very noticeable that there is a large amount of text just swirling around a few simple ideas, and the summary got it simple, like into a tweet. That was really, really nice. I wish everything could be summarized like that." So, so looking forward, what we are planning to do with Wikim going forward. So one thing is more integration of automatic summarization techniques and more machine learning to help out users. So we had a clustering component of Wikim where people could cluster comments at the same level into different clusters that were supposed to be sort of like topic models, but people didn't really use that so much, perhaps because it may have not have been good enough. So improving that, adding more machine learning, such as, you know, suggesting good places for summaries to be, could be really interesting. Thinking forward to other types of discussions, such as synchronous discussion, also discussions that are ongoing. So right now, Wikim is really good for a discussion that's finished. But say a discussion is ongoing, you write a summary, someone else replies to something, and now that summary is perhaps stale. So how do we take that into account? We want to do some crowdsourcing experiments to think about ways to take care of quality control, and also to figure out how much this would cost if someone wanted to, you know, pay for the service. And also, of course, field experiments. So thinking about who would do summarization, what's a good incentive, how would people actually use this in the wild? Some other things, so like I mentioned earlier, like presentation of the summary tree. Are there better ways to present it? How can we preserve context? How do we add more cues to guide people as they're navigating? And, you know, is there actually, you know, pros and cons of threaded versus non-threaded discussion? And then the last thing was thinking beyond discussion. So can summary trees be useful for just this like hyperspace, getting lost in hyperspace problem where you have a graph of linked documents? You know, summary trees instead are more of a tree shape. So there's sort of less room for you to get lost. There's always a parent, there's always a context there. So, you know, could summary trees be useful for somebody who's trying to get an overview of a topic, for instance, in Wikipedia? And yeah, that's it. So I have a preprint of the Wikim paper, but the final copy is not available yet. So email me if you're interested. And I do other work related to online discussion systems I didn't have time to get into. So moderation tools, tools for combating harassment, and also like automatic summarization techniques. Yep, thank you.
Thank you very much. So I think Jonathan has a question.
Yeah.
Actually, I'll let Giovanni go first because I can talk to you later. Giovanni on the IRC asked, I have a question for Amy. Do you think this system could work for summarizing things other than discussions, for example, reviews?
Yeah, absolutely. So I kind of got into that a little bit at the end with Wikipedia. I definitely think that reviews could be really a useful approach. So for instance, the problems I talked about with scale and redundancy definitely also happen in reviews. In this area, because there's no sort of threading of reviews, I could see automatic approaches being even more helpful because people have worked on automatic summarization of reviews, but not so much automatic summarization of discussion threads. So I think that, yeah, absolutely.
Okay, one more question from IRC. Volker asks, on the topic of trust, has there been thoughts on how to address negative summarization?
Yeah, so so definitely, like going forward, we want to do more studies where there is the possibility of malicious acts or people spamming the system. Some of the things, so far we've only done lab studies, so that hasn't been a problem, but we definitely want to, I mean, that's obviously going to be a problem in the wild. So some of the things we thought about were, for instance, like using community moderation or moderation by the people who had the discussion, for instance, like maybe they have to approve of the summary before it's written or posted, or people could write multiple different summaries and a specific summary could be upvoted. Other options include just, you know, having summaries, letting people rate them, and letting people, admins or community moderators know, like, oh, this is not rated highly, or this is potentially spam, and that sort of thing.
So we are at time, but we have a little more time, it looks like, if anyone else has questions.
So I have a couple for Besnik that came in late.
Well, I have one more for Amy then.
Okay.
How about that?
Okay.
I'm curious from your perspective, what are some of the real world use cases, specific real world use cases for this kind of tool? And obviously I'm thinking of wiki use cases, but I'm curious to know what are some of the use cases you were thinking of as you started to develop it.
Yeah, I think there are a lot of different use cases out there. If you can think of just, you know, discussions on the web where there are a lot of readers of a discussion, but you know, every new reader has to go through and read the entire discussion in order to get a sense of it. So basically any popular discussion could be useful for this.
I guess I was thinking more specifically of, like, when is it important that a discussion be summarized, right? What's at stake in a discussion being summarized?
Yeah, absolutely. I think, for instance, like deliberative discussions are incredibly important. So when, so one example would be like the polymath community that they are, you know, doing research collaborations within discussion forums and, you know, coming up with new math theorems. And actually, they are doing a summarization, but basically, it's just the like owner of polymath writing all the summaries of all the discussions themselves. So, you know, that's one obvious use case. And there are a lot of other cases where there are, you know, important or high stakes discussions going on where people are going to refer to it later because, you know, a decision was made or points were brought up that people then need to go and wade through.
Awesome.
Yeah, and I think Wikipedia talk pages is a perfectly good example as well.
Mm-hmm. Thank you.
Someone said that Hangout crashed. Are you guys? But I'm still experiencing everything here. Okay. Aaron's Hangout crashed. There you're back. Okay. Are there any other questions? We're a little 2 minutes over time.
I think Aaron had a couple.
Okay.
Yeah, so this is for Besnik. So user, what am I doing, asks about the system. How fast does this run? Can I run it in real time while I'm editing an article, or is this more of a process in the background and get an email in the morning kind of computation thing?
I would say the later. So it's there's quite some pre-processing involved. So I think it's yeah. So until you make the data available in such a format that you actually can run a query on a daily basis, if you imagine that news come in a daily basis, then this would probably take a bit of time. This would work fast in case where you have pre-computed all these features and so on for a snapshot of news, let's say, and then you could use it on real time. But if it's like on a daily basis, then this would probably take time.
Well, I think that we, Aaron, are you there again? Are you there? He's coming back. We made, Aaron, is there another question?
So sorry, I dropped out for the answer, but I assume that it happened.
Yeah.
The other question was just, is this software released open source?
So November is my target to actually release all the code and with all the explanations that are also in the paper, but also like with proper code documentation. So November might be a good target. When exactly November, I do not know, but November, I think, will be like when I will be publishing the code.
Great, thank you.
Thank you.
Thank you very much, Amy and Besnik, and thanks everyone for asking great questions. I think with that, we'll wrap it up for this research showcase.
Thanks for having me.
Thank you.
Thank you.
Bye-bye, everyone.
Bye-bye.